Hmm. Okay. So next, let's discuss the lecture 12, which is the reaction of electrophilic and nucleophilic nitrogen. So in the lecture 12, Punyamurthy sir have discussed about the nitrogen atom, which is nucleophilic and electrophilic. So summary will going to discuss here. So the Straker synthesis of amino acids from aldehyde is the first example. So imine formation. First imine formation is taking place. This ammonia will attack here. It will get open, and then proton transfer. Just we are doing like this in previous example. So we will get the imine, right? Weishmann, then proton transfer, then hydrolysis. Okay. Now after getting this imine, try this by yourself. If you are not getting, you can ask me. Then nitrile ion will attack here. Okay, and it will get open up like this. So this is the alpha amino nitrile the mixture. Okay, racemic mixture, because there is no chiral, sorry, there is no specific stereochemistry. It is a racemic. Okay, so after getting this one, the hydrolysis will takes place to give the corresponding alpha amino acid. How the hydrolysis will take place? You know everything we have discussed earlier. So it will attack here. Water will attack here. It will get open up like that only. You have to do the hydrolysis. Okay. Then proton transfer and other things will give you the corresponding alpha amino acid. Try this step again by yourself. Okay. If you are not getting, we will discuss simple hydrolysis. Then specific example we have here, which is this benzaldehyde, and the reaction of benzaldehyde with ammonium chloride and sodium cyanide. Next was HCl and heating. So here what's happening here, first imine formation is taking place. I will form the intermediate here. So you just do the reaction by yourself. So imine formation will takes place, correct? After this imine, what will be the next thing? Nitrile attack we have discussed, right? Nitrile attack. So here NH, right? After this one, hydrolysis. Hydrolysis will give you this product, phenyl glycine. Okay. So ammonium chloride is a mild acid here, because pK value is given, which is 10. That protonates the cyanide ion to give the HCN and ammonia. So the byproduct will get here HCN and ammonia. Okay. Next one is mechanism of Straker synthesis of amino acid. So that only the same thing. Imine formation we have to do here. We have discussed it already. So the lone pair will take the proton, and this ammonia will attack on carbonyl center, electrophilic center here, right? Which is given in here, right? Okay. So protonated aldehyde will become more electrophilic. That's why protonation is done in first step. Okay. So after the protonation, the attack of ammonia will take place to give the corresponding intermediate, this one. After this one, proton transfer will take place. Then water is a good leaving group. It will knock out and we'll get the imine as a iminium ion as a proton intermediate, protonated imine, right? Iminium ion. I already told you why we are calling it iminium ion, because it's a protonated imine. That's why it's become iminium. Then after this one, nitrile will attack on this electrophilic center and it will give you a alpha amino nitrile. So then the second part is given here, hydrolysis, how the hydrolysis is taking place. The nitrogen will abstract the proton from H3O, right? So water molecule will attack on nitrile group. I have discussed earlier also, here also, right? Here I told you it will attack here, right? That way only. So here the hydrolysis will take place, then we'll get this intermediate, right? After getting this intermediate, proton transfer will take place, then another water molecule will attack and it will get knockout. Okay, another water molecule will attack here and will get ammonia, knockout, elimination of ammonia, and then after that the proton abstraction will takes place by this ammonia, which will give the corresponding acid as a product. Okay, next, now we'll start the question answer session. We'll discuss the questions. So in this case, you have to find out the major product of the following reaction. So we have discussed many times. What is the arrow condition? It is methanol and sodium borohydride, right? We'll discuss the mechanism here. So first of all, this is a type of reaction of reduction, right? Reductive amination. So we have here electrophilic center, and here all of you know that here we have amine. So whenever we have these two combination, you have to make attack of amine on aldehyde carbonyl center, right? We'll get this intermediate like this way. So we will write for this one here. Okay, after getting this one, this is nothing but this intermediate. After this one, proton transfer, right? Proton transfer and elimination of water. This is proton transfer have taken place. Okay, this will knock out. We'll get here this one intermediate, correct? All of understood this one. Now we have sodium borohydride in reaction. So this is a hydride source. H minus. H minus will attack here. It will get the product and H, this one, right? Same. So this is the correct answer, which is here. So the mechanism is this one only. So I hope you understood the mechanism. Try yourself the other question of this type of question also. Other questions which is based on this concept. Okay. Next one. Predict the major product of the reaction. So here we have aldehyde, amine, right? Primary amine, aldehyde and ketone intermediate. So first of all, you have to do attack of amine on carbonyl center. So here we are doing the reaction. The mechanism is given here. this will attack on carbonyl center and it will get open up, right? On aldehyde, sorry. The attack will take place on aldehyde. So here we have these two aldehydes. So first of all, we'll do the attack on one aldehyde. I will write here like this way, and then this NH2 PR will attack here. Okay, so it will give intermediate. I will directly show here imine, right? So I will write here imine. Okay, we'll get the imine. After this imine formation, what is the next? We have here this substrate where the deprotonation will take place and enolate formation will take place, right? Then that enolate will attack on this iminium ion here and will get the intermediate. CHO will remain as it is and Ame, and here we'll get the got it. So this, after getting this intermediate, what will the next thing? This nitrogen will again attack on this aldehyde because this is a double Manish reaction, right? So it will attack here and it will form 1, 2, 3, 4, 5 member ring. 5 member ring. O minus, okay. And next to this one we have this group. Understood till here? After this one, proton transfer will take place and it will become OH, right? I will write here directly OH because detailed mechanism is given here and we have already discussed earlier, right? So after this OH formation, the proton transfer will take place and it will become H2O, which is a good leaving group, and then double bond will come over here. I will write the product here after the elimination iminium ion, right? This iminium ion formation will take place here. Okay, after this one we have here again the same reaction will repeat here, right? So the deprotonation will take place from here and this will attack on iminium ion and it will get open up, right? So we'll get something, the structure which will look like strained one, this way, right? So I will write here this way. Okay, it will attack over here and we'll get this intermediate. After this one, hydrolysis will take place and CO2 elimination will give the corresponding product as this one as a desired product. Okay, so this methyl is not PR group, I mentioned here PR. Okay, this is PR. So that's why we'll get this as a product, final product. So this is a double Manish reaction. You should follow the mechanism step by step to get this product. So you can follow this mechanism, which is a general mechanism for this type of reaction, to solve this question. Okay, I have given here hint. The next question is the major product of the following reaction is. So again here we have two aldehydes, amine, and here we have the same previous example only. We have to do the same way. How you will do this one? This is the mechanism only you have to follow for this one also. So the correct answer is this one. Follow the same way. We have already discussed many times this mechanism. So now I hope you can solve this thing. Okay. The next one is the major product of the following reaction is. So here we have H-Wheeler-Clark methylation. Okay. H-Wheeler-Clark methylation reaction, where always we have given ammonia, right? Amine. So it will attack on formaldehyde is given here. So rest of the thing will remain as it is. It will attack on aldehyde. Okay, formaldehyde. Then after this one, what will the next thing? Proton transfer. So proton transfer will take place. Okay, this one will get like this intermediate. After this one, we have acid also. Acid. So this acid will give the proton here, protonation for this OH group. Okay, so this will again become acid is giving proton here. Got it? Now what will be the next thing? This lone pair will push here and this will knock out. So amine formation will takes place. Got it? All of you are clear here? I hope all of you are clear till here. Okay. After this one, what is the next step? Again, we have acid. So CO2 elimination will take place and hydride transfer will take place over here. Okay. As shown in this step, last one. So we will get here okay, methylation. So N-methylated product will observe here. Now after getting this one, we have to repeat the same thing again. Now it will again attack on this lone pair, because here we have methoxy group, this will attack here, and then proton transfer will take place, which will give this as a product. This is the correct answer. You have to do the first methylation, then you have to make attack on aromatic ring. Then question number 5, predict the major product of the reaction. So here we have cyanonitrile group and then sodium acetate and methoxy nitro group. Okay, so this reaction is a nitration reaction. As we can see here, we have cyano group in starting material here, which will react with the sodium ethoxide, where the ethoxide ion will attack and take up the proton. So here this is a base we are using, so it will extract the acidic proton. So here we have acidic proton, 2 acidic protons. So proton abstraction will take place from here. And then, because if we will write this by opening this one, this will look like this way, right? So that's why we can write this in allene form also, right? This way. So which is nothing but this one only. So then after this one, this nucleophilic attack will take place on nitro compound, right? Nitro group. So after this one, this will get open up and we'll get this type of intermediate. After getting this intermediate, methoxy will, this negative charge will push here and methoxy will knock out as a leaving group. So because methoxy is a good leaving group, it will get knocked out. So we'll get nitro here. After the nitro group insertion, hydrolysis will take place on cyanide to give the corresponding acid, right? We have discussed already the mechanism of hydrolysis, how it happens. So water is attacking on the carbon of nitrile group, so you have to follow that mechanism to make it acid. Okay, go and revise that mechanism, we have already discussed in this class. So after getting this acid, the CO2 elimination will take place to give the corresponding nitro compound. So the correct answer is the option number B. Then the next question is, the major product of the following reaction is. So here we have reaction of sodium cyanoborohydride and this hydrogen. Okay, done. So you have to do the same way reaction. So this is homework for you. I'm giving you the answer here and you have to solve this by yourself. If you are not getting, we will discuss in next class, because in this class it is difficult to cover all the questions. Okay, next one, predict the major product of the reaction. Here again we have aldehyde and reduction substrate, reduction reagent, which is sodium cyanohydride. Okay, sodium cyanoborohydride. Here we have product, you have to solve it by yourself. So nothing, this will nothing but methylation will take place. So nitrogen, I will give you hint, it will attack on aldehyde and then the hydride transfer will give you the desired product. We have already discussed this type of mechanism also. So the methylation will take place on this place and you will get the correct answer as option number A. So go and solve yourself. If you are not getting, we'll discuss in next class. Okay, next question. Predict the major product of the following reaction. Again we have formaldehyde and acid. We have discussed this question also. What you have to do? You have to make attack of this nitrogen on aldehyde always. Right? This is the Ashwiller-Clark methylation reaction. So here after this attack we'll get in this intermediate. Then it will take the proton from acid and it will become H2O to get the undergo the elimination, and after the elimination we'll get the iminium ion, and this iminium ion will further attack by hydride ion to give the methylated intermediate, which will after the proton and elimination will give the methylated product. So the correct answer is option number B. Okay, so methylation is taking this. So the same method you have to repeat twice because here we have two protons. So I told you the we are using in this case excess of aldehyde and acid. So that's why this reaction will end up only at the tertiary amine formation. Okay, the tertiary amine will be the final product in this case because of excess use of aldehyde and formic acid. Then the next question is predict the major product of the following reaction. Here this reaction is Becquerel-Burke's reaction. Okay, so ketone proceed reaction with ammonium carbonate in presence of cyanide and to afford the hydantoin, which could be hydrolyzed to alpha amino acid. So here we have ketone. Okay, this ketone will get attacked by cyano group. Okay, so first of all reduction is taking place. This reagent is used for reduction. We have discussed how this will take place. Ammonia will attack on this carbonyl center. This will get open up, and then proton transfer and water elimination will give you the amine. Then primary imine formation will take place. Then after that primary imine, this cyanide will attack over here. We have discussed this mechanism also earlier. Just I am reminding you again. Okay, so this is a revision only. So this will attack on this center and will get here this intermediate. After this one, the lone pair of electron will attack on CO2 molecule and it will give you a corresponding amide intermediate. Then proton transfer will take place to give this intermediate. After this one, this lone pair of oxygen acid will attack on electrophilic center of nitrile group and it will get open up. We'll get this type of intermediate here, and then after this one proton transfer will take place here to get the intermediate this way. So proton is getting transferred from here. Okay, after this one what will be the next thing? This nitrogen lone pair will push electron here and it will get open. Okay, so we'll get this open. Yeah, so after getting this one, this intermediate, this will get open up. Okay, then the lone pair of nitrogen will again attack on the carbonyl center and it will give you this intermediate, and then proton transfer will results in a cyclic 5-member product here. So that's how we are getting this as a product. Okay, so this is the correct option, the Buchrer-Bucks reaction. Okay, next, predict the product of the following deproduction reaction. So as mentioned here, this is a deproduction reaction, so you can directly write the product here. The deproduction is taking place, right? This one, the mechanism is given here. So how the deproduction is taking place? First we have piperidine. So the lone pair of nitrogen of piperidine will attack here and it will abstract the proton, right? So here it will give you an intermediate which will look like this one, FMOC, right? From FMOC. What is FMOC group? Anybody knows about this one? It's nothing but which is given here, this one. This is FMOC group. Okay, so here we have FMOC group. So rest of the thing will remain as it is. This group you consider R only. Okay, so here we have proton here, right? Proton abstraction will take place from piperidine and then it will look like this way, double bond, and this group will knock out. Like that deproduction is taking place. Okay, so this group we are getting eliminated. In our case, this is NFMOC protection, so this will be NH2. Okay, sorry, in our case it will be NH and R group. This is the R. I told you to consider this as a R group. Okay, after getting this one, what will be the next step? Then the piperidine, protonated piperidine will protonate this one and CO2 elimination will take place. Lone negative charge will push here and it will get knockout. CO2 elimination will take place and protonation will be done by this one, piperidine, protonated piperidine, and we'll get primary amine as a product. So here you can see that R is there, R group is there, and this one is our NH group where we have this one. Okay, I told you to consider this as a R group. Okay, so NH2 primary amine will form over here, so that's why this R group is same only and we are getting primary amine, which is the correct answer, this one. So the next question is, the major product of the following reaction is. So here you have lithium acetylene. Okay, lithium acetylene and water on arrow. So what will be the product here? Yeah, see here, when we have discussed this reaction. Good evening everyone. I hope I am audible to all of you. Myself Sana Sheikh. I am a 4th year PhD student at IIT Bombay and I am a NPTEL TA for the course which is entitled as Principles of Organic Synthesis, and the course instructor is Professor Punyamurthy from IIT Guwahati. So we have already done week 5 classes. So today we are going to discuss the week 6 classes, which include the lecture 11 and 12 of Punyamurthy sir, which is available on YouTube. So let's start today's session. So we are going to discuss the lecture 11, which is the reactions of imines and enamines. So we will do the quick summary of those lectures and then we will start problem solving session. So the reaction of imines and enamines we are going to discuss here. You can see the first example which is given here. So the name reaction of this one is Bosch reductive amination. So Bosch reductive amination, the reaction name is given here. So we'll discuss the mechanism. So talking about the reaction mechanism, the iminium cation formed by the condensation of carbonyl compound and amine reacts with the nucleophile hydride to give an alkylated amine. So here we have ketone, right? And we have amine, right? So what will do? Lone pair of amine will attack on aldehyde, carbonyl center here, and this will get open up here, right? Arrow pushing. After getting this intermediate, what will be the next thing? Proton transfer. So after proton transfer, the water molecule will become a good leaving group. So here again lone pair of nitrogen will push here, and this water molecule knock out, and we'll get the iminium cation as an intermediate. After getting the iminium cation, the hydride ion hydride as a nucleophile will attack on this iminium ion, this electrophilic center of iminium ion. So here we are using here hydride source, sodium cyanoborohydride. Okay, so because of that, because this is a hydride source, hydride will attack on here, and this will get open up, and we'll get the corresponding amine as a product. So in this case, what is the conclusion? Is we are starting the reaction with ketone and ended up with amine, and the iminium cation is a intermediate. Okay, so the another example is given here, reductive dimethylation of aniline. So here we have aniline, right? So dimethylation, we'll discuss this again in question answer session. So till that time you just try to solve this one by yourself. I'm just writing here how you have to write during the solution of the mechanism. So here amine, here we have primary amine, it will attack over here, it will get open up like this only. The above mechanism you have to follow for this one, and you will get this as a product. So try yourself. If you are not understanding, then I will explain again, or you can ask me in next class also if you are having doubt later. Then next question is, next topic is Ashwiller-Clark reaction. So here we have Ashwiller-Clark name reaction. What is this reaction? So this is a reaction for synthesis of nicotine. Nicotine is present in tobacco. All of you know this thing. So this is a natural product. So here we are going to discuss the mechanism. So we have here formaldehyde and formic acid, right? At 80 degree we are heating it, and we are getting the here product. Okay, so we'll discuss the mechanism, how the reaction is proceeding forward. Am I audible to you? Please say yes. Okay. Okay. So here the Ashwiller-Clark reaction allows the methylation of a primary or secondary amine to the corresponding tertiary amine. So using excess formic acid and formaldehyde, avoiding the formation of quaternary ammonium salts. That's why we use here excess of formic acid and formaldehyde to avoid the formation of quaternary ammonium salt. So the reaction between the amine and formaldehyde generate an amino alcohol intermediate. You can see here amine will attack on formaldehyde, and will get the amino alcohol intermediate, this intermediate. How we are getting this one? This nitrogen will attack on carbonyl center, and it will get open up, right? Then this negative charge will trap the proton here from here, right? So that's why this moiety will knock out if protonation will takes place, right? So after this one, we'll get the amino alcohol intermediate. After getting amino alcohol intermediate, dehydration will takes place, which will deliver an iminium ion. So how the dehydration will take place? Proton transfer. We have already discussed this one, right? So proton transfer, then lone pair will push electron here and it will get knock out as H2O, right? So then the next step is hydride transfer, right? From where? So here you can see that this moiety was knocked out earlier from formic acid. So we have this one, right, in reaction. So the CO2 will release, if O minus will attack here and it will get knock out. So H minus will knock out after CO2 elimination, right? So this is a hydride ion and hydride transfer will take place. So where the hydride transfer will take place? Here, right? So after the hydride transfer, we'll get the amine, methylated amine as a product. Then because we are using here excess of formic acid and formaldehyde, that's why again the same reaction will takes place, because still we have one hydrogen here, right? So that's why again the nitrogen lone pair will attack on formaldehyde, same mechanism, and we'll get the iminium ion as an intermediate here, like this one, right? So after getting this iminium ion, again the hydride transfer will take place and we will get the dimethylated ammonium salt, okay, dimethylated. So this process is repeated here. It is mentioned in mechanism. This process is repeated until a tertiary amine is generated, at which the point at this point the reaction will get stopped, because now here we don't have any proton on nitrogen which can get transfer. All of you know that in this step proton transfer was taking place, right here. So because of hydrogen only, if proton is there on nitrogen, then only it can get transferred. So after getting the tertiary amine, it is not possible. So this will be a final product. Final product. Okay. Shall we move further? Yeah. Next one is stock enamine synthesis. I hope most of you have listened about this one. Have you heard about this one, Stark enamine synthesis? So the Stark enamine synthesis involves the alkylation or acylation of enamine with the corresponding reagent. So this type of reaction is very famous and it is mentioned in Claydon as well. So we'll discuss the general feature of the reaction. So the general feature, talking about the general feature, the preparation of enamine takes place with one equivalent of secondary amine, right? So here we have secondary amine. And then the second point is unsymmetrical ketone deliver enamine regioisomer, being the less substituted favored. But here we have example of symmetrical. We'll discuss unsymmetrical also in later examples, okay? So we'll start with symmetrical first, but the second point is about the unsymmetrical. Thus the alkylation takes place less saturated side of the ketone. So we'll discuss this in another example. The third point is tertiary alkyl halide undergo elimination rather than alkylation. So when the tertiary alkyl halide will form here, it will undergo a elimination rather than the alkylation. We'll discuss by the example again, this one. And the fourth point is the best electrophile are activated alkyl and acyl halide. However, Michael acceptors and epoxides can be used. So we'll discuss the use of stock enamine synthesis in reaction, okay? So the fifth one is the alkylation of enamine takes place under neutral condition. Beside polyalkylated product are seldom observed. So just forget about these points. We'll start doing the mechanism. You will learn each and every point. So remember these things side, but we'll discuss by mechanism. Then everything, every point will get clear to you. Okay. So we have here symmetrical ketone and we have secondary amine, right? So what will happen first? Always all of you know that secondary amine will attack on carbonyl center and it will get open up. Here it is given, right? After this one, we'll get the enamine as the intermediate. Why it's called enamine? Because we have double bond in, right, and amine here. So in amine. So that's why it's written as enamine. Okay. So this is enamine we are getting as an intermediate. Now after getting this one, what's the next? We have learned about the aldol condensation and aldol reactions, right? So in that case, enolate formation is taking place. When the enolate formation is taking place, that time you know how the reaction is taking place. Double bond attacks on another moiety, right? In the same way, here also we have to do the same thing. I- this is nothing but the inolate type of substrate only. So in inolate we have oxygen here, right, and here we have nitrogen. So that's why, so because it's also have lone pair, so it will push here and this double bond will attack on the methyl vinyl ketone. So this is the nothing but the reaction is like Michael addition reaction. Remember Michael reaction. So this is the type of Michael reaction. Now that's way only it will react. So double bond will get shifted over here and it will open up, right? We'll get this as an intermediate. This quaternary ammonium salt as an intermediate will get here. Then water molecule we have in the reaction, right? Here H3O. Okay. So water will attack here and it will get open up. Now because this is a hydrolysis process, so again this proton transfer and then lone pair push will takes place to get the corresponding product here, right? So this is the hydrolysis step. Understood? Now if talking about this part, this is the nothing but enamine synthesis only. How it's yeah, I have already explained this one. So lone pair will push here, it will get knockout as a H2, right? Then after this formation, this intermediate proton abstraction will take place from base. This OH minus will act as a base. Okay, so this is the Stark enamine reaction. We'll discuss other examples also in detail, so don't worry about this one. Acylation, alkylation, we will discuss all these things. And this RX also, instead of RX here we have MVK. Okay, so in other cases we are getting a alkyne atom also. Sorry, alkyl halides. Alkyl halides also react same, but here we have MVK, methyl vinyl ketone. Okay, so next one is the next reaction is Robinson-Schwarz reaction. Okay, Schwarz reaction. So the originally the reaction of methylation, methylamine and succinaldehyde and acetone dicarboxylic acid is used to form the tropinone, which is called as a Robinson-Schwarz reaction. So we'll discuss the mechanism here. So from an formal point of view, this is the mechanism is given here. This is nothing but the double Manish reaction. We will discuss how the Manish reaction is react. We have already discussed Manish reaction in previous classes, right? So here we will discuss the Robinson-Schwarz reaction, which is nothing but the double Manish reaction. Okay, but we'll start the reaction with succinaldehyde, right? This intermediate is known as a succinaldehyde. So now what will happen? We have here methylamine. Methylamine will attack on this carbonyl center of succinaldehyde and it will get open up. Correct? After this one we have discussed earlier, proton transfer will take place, then H2O will become good leaving group and it will leave, and we will get double bond over here, which is this one, imine. Okay, we'll get imine. Sorry, imine. Okay, after getting this imine, what is the next step? Because again we have here nitrogen and it will attack as a intramolecule. First inter was there, then intra. This lone pair will attack on this carbonyl center and it will get open up, and we'll get this as an intermediate. After this formation, now this can act as a nucleophile as well as and base also, right? So here we have O minus, so it will abstract the proton from the acetone dicarboxylic acid. This is acetone dicarboxylic acid, right? So from here, the acidic proton abstraction will take place. So which proton is acidic? Either this one or this one, right? So one proton abstraction will take place and negative charge will generate over here, which will form the enolate ion, most stable enolate ion, right? Because of the conjugation system. So after the enolate formation, what's the next? Like aldol reaction only, it will attack, double bond will attack on imine, right? Here after the proton abstraction it will become OH, that's why we have written here OH, right? So it will attack on imine and it will get open up, double bond will get open up and charge on nitrogen will become neutral. Okay, so after getting this we will get this 6 as a intermediate. Okay, tertiary amine. So here we will get the tertiary amine. Then after the formation of this tertiary amine, what is the next? Now we'll discuss the second part of the mechanism, right? Till here everybody understood 6, right? We got the 6 here. You can link from here, right? We have 6 here. Okay, so after getting the 6, what's next? Again intramolecular reaction will takes place. So nitrogen we have here and lone pair will take this proton, okay, abstract this proton and will get the, and this oxygen, this bond will shifted over here and it will get negative charge, will get negative charge over here, right? This, right? So this intermediate will get here. After this intermediate, then the proton transfer will takes place like earlier we were doing, right? Proton transfer on this atom. So this will become OH and H2O is good leaving group, so it will leave here water molecule and we'll get the iminium ion, iminium salt, right? Iminium salt. Then after getting this iminium salt, what next? Because we have here negative charge, so it will take the proton. So here after getting this iminium salt, proton abstraction will takes place from this position, right? So enolate formation will takes place, we'll get here enolate, right? After this enol formation, this double bond will attack on this carbon and it will get open up here. So this type of intermediate will get here. Got it? This double bond is, this is a Manish reaction only, the second Manish reaction here taking place. So that's why this double bond is taking is attacking on this iminium ion, right? Earlier in previous case also we have discussed that here this double bond was attacking on iminium, right? This is the first case, and here again the same thing is happening here. Iminium is, it's double, this double bond is attacking on iminium ion and we are getting this intermediate. Okay, then after this one the CO2 elimination will takes place from here and here. So this is a carboxyl rung, beta decarboxylation, and we'll get here our corresponding ketoamine product. Okay, so practice this mechanism by yourself. The same thing you have to repeat 2 times, double Manish reaction. Okay, Next, Hell-Bollard-Zelensky reaction. So in this case, at alpha bromination is taking place. Okay, so the Hell-Bollard-Zelensky reaction allows the synthesis of alpha halocarboxylic acids with an halogen and phosphorus trihalide at higher temperature. Heat is given here. Okay, so the initial product of this Hell-Bollard-Zelensky reaction is an alpha haloacyl halide. We'll discuss the mechanism. And hydrolysis followed by the tautomerization will give the corresponding product. So the harsh reaction condition is used in this case, higher temperature and more reaction time. This reaction is only feasible for bromo and chloro compounds, but the fluorination and iodination of carboxylic acid under this condition is not feasible. So what happening first? The carboxylic acid react with the phosphorus tribromide here. How it reacts? Lone pair of oxygen is attacking on phosphorus and one bromide will knock out. After that bromide Br minus knockout, that will again attack on this center, carboxylic center, right? It is written here, this one. Okay, it will attack on this one. So formation of acyl bromide will takes place. Then tautomerization here. After getting this one, all of you understood till here? Bromine will attack over here and it will form this intermediate. After this one, this lone pair of oxygen push here and this group will knock out OPBr2. Okay, OPBr2 group will knock out. So we will get here this as a byproduct. After getting this one, we are having acyl bromide in hand. After this acyl bromide, the tautomerization will takes place, ketoenol tautomerization. Okay, so proton abstraction will takes place from here and then we'll get the tautomerized enol. Then it will, this double bond will attack on bromine, right? Br2, we have Br2 in reaction, so on bromine atom, and the another bromine will knock out. So here Br minus again will knock out, which will take proton to give the HBr, right? Okay, HBr. After this one, hydrolysis will takes place, which will give the bromo carboxylic acid. So we get this one as intermediate, right? Then hydrolysis will takes place where the water will attack on carbonyl center and it will get open, right? And after that again this will push back and bromine will knock out to give the alpha halo carboxylic acid. Similarly, when we will use the other nucleophile instead of water, it will attack on carbonyl center and then it will get open up and the further pull of electron will knock out the bromine ion to give the nucleophilic attack of nucleophile will attack here to give the corresponding ketone instead of acid, right? So we can get other ketone also if we will use other nucleophile instead of water. Okay. So suppose if instead of alcohol we are using some alcohol, right? Suppose isopropanol alcohol. So that time what will happen, or ethanol, whatever it will be, ethanol, suppose we are using ethanol, right? So this nucleophile will attack here and it will get knocked out to give the corresponding ethyl ester. हर बार क्यों होता है ऐसा?